Welcome back to another physical sciences lecture, and today we are looking at projectile motion. And the only cases of projectile motion we consider in this course are horizontal projectile motion. So you might have, say, a cliff face, and we've got a sample problem like this, where maybe like a golf ball or a rock is thrown off or hit off at horizontally, and because of gravity, we end up getting a curved motion downwards. So gravity is the only force acting on it. So we have this horizontal motion initially, and then we get a curved path down. Okay. So we don't worry about anything if you see a problem like this, where it says it has initial velocity like that with an angle, then you don't need to worry about that in this course. Okay. Using the techniques we have learned for analysing a straight line, so we have vertical and horizontal components. So the example I used up here, we had a horizontal motion initially, and then because we have gravity acting on the object, the path will be curved because the velocity will increase in a downwards motion over time. So the techniques we have used are our SUVAT techniques. So that is what we are looking at. Okay, we're just going to have a look at some of the properties of horizontal motion. I'm not sure what happened there with the box. It's not the best. Oh well, not sure what happened there. Let's go back. All right. So if friction is ignored, there are no forces acting on a projectile in a horizontal direction. This means that the horizontal acceleration is 0 meters per second. So that means that we've got a constant velocity. Okay, and they state here, for this reason, we can just use this equation to calculate the velocity. Another way that you can look at it, if you want to stick with your SUVAT equations, if you have S equals ut plus half at squared, and acceleration is equal to 0, then this factor cancels out. That's 0. Then we're left with S equals ut, and then we might divide both sides by t, so we end up getting u equals s over t. And because there is, and since a is equal to 0, that means v is equal to u, and so those two equations are in fact the same. So s equals u over t. So you can always rely on your SUVAT, writing down SUVAT and going to your equations of motion to solve these problems anyway for the horizontal, so you don't have to remember which one just relies on this one and that one. Okay, so vertical component of motion. This is analysed exactly as discussed in the previous pages on vertical motion. However, because the projectile is fired horizontally, the initial velocity u is always 0, so it's always 0. So we'd never have an upward velocity or a downward velocity. And the displacement s is the height at which the projectile was fired. Okay. The vertical component of motion is analysed using the following formula, and they're just your equations of motion. And we have some kind of properties of the vertical and horizontal motion. So vertical, we have downwards, and horizontal is crossways. Okay. So the displacement is going to be is called the height, and for the vertical, and range in the horizontal. For vertical, the initial velocity is always 0 meters per second, and our final velocity is the vertical component at which the projectile hits the ground. So it's going to be downwards. Horizontal velocity is constant and always is going this way. Okay. Acceleration is 9.8, I like to put in 1 meters per second down. It says squared down, and 0 for horizontal. So this is down, that is the horizontal. And the important point is that t is going to be the same. So it's always the same value. So that's a very important point. The most involved questions about projectile motions are ones asking for velocity at which the projectile strikes the ground, and it's sometimes called the final velocity. Because the velocity is a vector, we need a direction. So we need both the speed, so that'll be our final vector, like that'll be our magnitude of the final vector. And then we need to get the angle from which it hits the ground, and it's like this one. And we always call this, because this is the horizontal along here, so the angle, theta, is always below horizontal. That's the direction that we call it. So rather than northeast or northwest or one of those directions, we call it below horizontal. Okay, so we have a sample problem here, and I'll show you how to get the information for horizontal and vertical components in the next video.